So today's lesson is on vectors. And again, this is another topic that you may have learned in pre-calculus or you may have heard in physics or somewhere like that. The first, most of the examples actually I'm going to show you today are from things related to pre-calculus. And there's quite a few examples today, so starting with like when I get to example 14, that's where the calculus actually comes into play. But the first ones I'm just trying to get you to see what a vector is, what it looks like, and how you work with it. So first of all, there's something called component form of a vector. And with component form moves, basically a vector looks sort of like a line segment, and it moves the line segment from wherever it is to 0, 0. So for example, let's say that I want to find the component form of the vector from -3, 5 to the origin. So what that means is that there is a vector at -3, 5, and the direction it's going is the origin, and there's a little arrow here at the end at the origin. And so what it does is it picks up that line and it moves it to where the direction is the same, like it's still going with the same slope, but instead of starting up at -3, 5, it starts at 0, 0, and we want to find out what this purple form is. So what you do, the origin is 0, 0. Wherever it's going to, you start with that number and you subtract. So here you would do 0 minus -3, and then you would do 0 minus 5. The component form comes out to be 3, -5. And that makes sense because if I went over 3, and if I went down 5, I would end up with this one right here. So basically I'm just moving the blue to the purple. Component form means that you start from 0, 0. So same kind of problem. Let's say that it said from 2, 1 to -1, 5. You don't have to graph it, but I just want to explain what the graph is doing. 2, 1, -1, 5. And so from 2, 1 to -1, 5, that's the way the vector would look. And again, I'm wanting to start it at 0, 0. And I'm wanting it to be that same direction. And I put the arrow at the wrong place. Because if it's going from 2, 1 to -1, 5, it's up in this way, I'm sorry. So I'm trying to start it at 0, 0, same slope, but go up this way. And I need to figure out what the ending point is. That ending point is the component form. And again, what you do is you start with the second one where it's going to. So -1 minus 2, and then 5 minus 1. Okay, last one on this kind. Let's say that it told you that you had a vector AB, or you were looking at a vector AB, and it tells you that A is 4, -3, and B is -2, 1. Basically, this is saying that you're going from A to B. So this is the from, and this is the to. So to get the component form, we would do -2 minus 4, and 1 minus -3. Now, the other thing about vectors is that it has magnitude and it has direction. Magnitude is a distance. Direction is an angle. So, if I have the vector 3, 3, and the question is asking me to find the magnitude and the direction, I'm trying to find the distance, and I'm trying to find the angle. So first thing I'm going to do is I'm going to graph it. The vector starts from 0, 0 and goes to 3, 3. The distance I'm trying to find is that blue line. The 3, 3 is what makes this triangle. since that's the over part and the up part. So to find the blue part, I just do the Pythagorean theorem. The square root of 3 squared plus 3 squared. That's the square root of 18. That's the distance. I also want to figure out this angle. Whenever you make the triangle, the angle with the x-axis is the angle that you're looking for. Now, there's several ways I can figure out the angle. I'll show you a couple ways so you can do it whichever way you want. If I know the two sides are the same, I know that this is an isosceles triangle, so I know that the angle is pi over 4. So if I were writing down the answer here, I would write square root of 18 and pi over 4, because that's the magnitude and then the direction. Now, if you didn't know what that angle was, 3 is opposite that angle, and the other 3 is adjacent to that angle. This is opposite and adjacent. Well, that means that tangent of the angle is 3 over 3. So in your calculator, you could put tangent inverse of 1, and then that would give you the pi over 4. It would give it to you in a decimal form, so that'd be kind of strange trying to get the decimal, but I do want you to know what that fraction would be. If you changed it to degree mode, you would get 45, and then you could change it to pi over 4 if you wanted to. Alright, here's another one. 3, 0 is the vector. Here's where the point would be located. It's coming from 0, 0, so the magnitude is just the length. So the magnitude is 3, because the length from 0, 0 is 3. And the direction, again, is the angle. And in this case, since it's over here where 0 is, I can say that that is 0 degrees, or I could say it's 2 pi. It depends on how the problem's defined. So we would write 3, 0, or we would write 3, 2 pi. Okay. Let's say that we had 0, negative 2. So here's my vector. The magnitude is how long it is. Well, I don't have to make a triangle. It's not out somewhere. I know that the length is 2, so 2 is the magnitude. The direction is the angle. I'm coming from 0, 0, so that angle would be 3 pi over 2. Alright, here's another one. Negative square root of 3 and 1. There's the vector. I'm going to go ahead and make my little triangle here. I know that the magnitude is the distance of that purple. And since I know, I'm going to get rid of that negative because I know that's a length. Since I know that that's square root of 3, and I'm going to rewrite my 1 over here, then that's 1, I can do Pythagorean theorem. Square root of 3 squared is 3, 1 squared is 1. I get 2 for the length of that side, so 2 is the magnitude. And then the direction is the angle, and it's the angle from the x-axis, so I need that whole angle there. But if I could find this little bitty angle, if I could find that angle with the star, then I can subtract from 180 to get the blue angle. So a couple ways you can do it. I know that that star angle is actually a 30-degree angle because this is a 1 square root of 3, 2 triangle. And I know if I did 180 minus 30, I would get 150. And now to change that to radians, because you need to be in radian form, I know that that would be 5 times 30, so that is 5 times pi over 6. So my angle is 5 pi over 6. Now, if you had trouble getting that angle, realizing that it's 30, you could do like sine of the angle is 1 over 2, because that's opposite and hypotenuse. And then in the calculator, you would get your pi over 6, or you would get your 30, and then you could, again, subtract to get the 150 or the 5 pi over 6. But this is the final answer. If you could recognize those triangles, those special triangles, it'll make it a lot easier, because most of them will be special triangles. Okay. Okay, here's another one. 3 and negative 3 square root of 3. So here's my little triangle. 3 square root of 3 is there. So I know that over 3 is that, and down 3 square root of 3 is that. My magnitude would be this distance here. So I would do the square root of 3 squared plus 3 square root of 3 squared. That would be 9 plus 27, which is square root of 36, so it's 6. So my magnitude is 6. My direction is going to be from the x-axis, that big green angle, but I'm going to look for this angle here. Again, this is a special triangle. I can tell because the 3 and the 6, if I multiply the 3 by 2, I get 6. If I multiply 3 by square root of 3, I get 3 square root of 3, and that's the relationship of a 30, 60, 90. So this angle is 60. If I take 360 and subtract 60, I get 300. 300 is 5 times 60. So my angle would be 5 times pi over 3, because 60 is pi over 3. Again, if you didn't know, you could do like sine, cosine, or tangent of the angle equals one of those others and do the inverse. But I think if you'll recognize your special triangles, it won't be too bad. So now we're going to go the opposite direction. Let's say instead of given the component, let's say that you're given the direction and the magnitude. So 5 here is the magnitude and 90 is the direction. So if 90 is the direction, I know that I'm up here. The 5 is just how far you are from 0. And component form is just what point that represents. This point represents 0, 5, so that's the answer. Okay, so here's another one. Again, 4 is the magnitude. 240 is the direction. So 240 would be in the third quadrant. 4 is the distance, so it's like the length of the hypotenuse. Alright, if that's 240, then I know that this is 180, so I know that this is 60, because that's how much more you need to make 240. I would make the triangle, and if I can find this side and this side, that'll give you your x and your y. If you know the relationship between a 30, 60, 90, you'll realize that across from a 90 is 4, so across from 30 is half of that, and across from 60 is square root of 3 times that. So it's going to be 2 and 2 square root of 3. If you don't know that, you could do sine of 60 equals opposite, which is the y, over 4, and then cross multiply and solve for y to get that. But again, if you know the special triangles, it does make it easier. So your point is negative 2 square root of 3. So you find those two sides, but then you do positive negatives depending on if you're going left or right or up or down. Alright, here's another one. Negative 3 is the magnitude. 135 is the direction. And this should really be a positive 3, sorry. Because it's a magnitude, it's a length. Alright, 135 is in the second quadrant. There's my side, that's 3. Make my little triangle. I know that this is x and this is y. Since that's 135, I know that this is 45. And the relationship here is you divide the hypotenuse by square root of 2. So this is 3 over square root of 2 and 3 over square root of 2. Again, you could solve it using sine or cosine if you wanted to. But the point's going to be negative 3 over square root of 2 and 3 over square root of 2. Negative for the x because you're moving left, positive for y because you're moving to the positive. Alright, another way vectors might be written is they might have like a bold letter. They might like have a bold A, or they might put an A with a little line over it. And this is the component form. And what it would be asking you is to find the vector given, and then also to find its magnitude. So if it asks for you to find 3A, that just means that you multiply the A ones by 3, and you multiply each of them. So you would get 6 and 3. If it said to find the magnitude, magnitude is sometimes signified by an absolute value, then you just you do the Pythagorean theorem with that, which is basically just the square root of each of those two things squared. If they wanted you to find A minus B, you just subtract just like it says, and you start with A. 2 minus negative 1, 1 minus 5. And then if it wanted the distance or the magnitude, you do Pythagorean theorem with that. 3 squared plus 4 squared, so you get 5. Now we're ready to talk about the calculus of vectors. There is something called the position vector, and that's kind of the vector that we've been talking about. It might be in terms of t. It might not just be numbers. And so here's our position vector. If I want to find the velocity vector, basically I just find the derivative of each. If I want to find the acceleration vector, I just find the derivative of each. So if you're given the position, you just keep finding the derivatives for velocity and acceleration. Now, you might also be given a velocity vector, and it might ask you some questions about position and distance. Let's say it told you that here's the velocity vector, and the position at t equals 0 is 1, 3. So maybe the vector represents height and weight, and so the position at t equals 0, that means the height is 1 and the weight is 3, or something like that. The question might be asking you to find the position at t equals 2. It's been a while since we did position and velocity and acceleration, but basically what you want to do is you just do each part separately, like you find the position of the x part of the vector, and then you find the position of the y part of the vector, and then you put them together. So if you remember from a long time ago, position, if I'm trying to find it at 2, and since I know what's going on at 0, I'm going to go the integral from 0 to 2 of velocity. So I just do it, and I do it separately. I do each part separately. If I do that, I get 5.333 if I do it in the calculator, and 6.389. So that's like where you are now at this time, or how far you've moved from where you started. But since I know that I started at 1, 3, then I add 1 and 3 to each of those. So my position is 6.333 and 9.389. So you do it very similar to everything that we've been doing before. It's just that you have to do it twice because you have two parts of the components. Let's say that I was doing the same problem, and the question instead said find the distance from 0 to 3. And I'm still going to use that same velocity vector. Distance is basically arc length. So I do the integral from 0 to 3, and then I do the derivative, which, so because this is velocity, each of these are already the derivative, and then I square it. If you remember that distance is the integral of the absolute value, well, the absolute value of a vector is where you do the magnitude, so you do the square root of each component squared. And that's also arc length. let's say it asks for speed at t equals 2. Speed doesn't come out to be a vector necessarily, but what you do is you find the velocity at t equals 2, which means using this equation, we're still back up here to this velocity equation. You just plug in the 2. There's the velocity. The speed is like the distance again, and it's like the magnitude, so I do the square root of each thing squared. You get 10.890. Okay, so there's 4 try problems. Here's 2 of them. First one says find the magnitude and direction. Remember, this is component form, so like you graph it, and then you figure out the distance of the line and then the angle. And the next one, find the component form where the magnitude is 10 and the direction is 270. Remember that 10 is a length, 270 is an angle, so you do the angle and then 10, and then you can figure out what point that would be. And then the last one is the calculus part. If I want to know position and distance, I'm starting with the velocity equation here. I know that the position at 0 is 3, 4, and I want you to find the position at t equals 5, which will give you an x and a y component. And then I also want you to find the distance from t equals 0 to t equals 5.